Hello and welcome to Education at SSBJ online video tutorials. We were in chapter Motion of class 9th CBSE. In the previous videos we have studied about equations of uniformly accelerated motion. In this video tutorial, we shall understand where all and in what all situations we can use those equations. But first of all, we shall once again recapitulate and try to understand the meaning in short of these equations and the symbols used in these equations. To start with, we need to recall the meaning of uniformly accelerated motion. What do you mean by uniform acceleration? Let us suppose a car is moving on a straight line. And why straight line? In 9th class we are working on those situations where the vehicle is moving on a straight line motion. So when the car moves with a velocity, right? And when the car moves with a velocity, the velocity and the speed both are same here because a vehicle is moving on a straight line. So either I can call this as a velocity or speed, right? So if the car moves in a straight line and if I can show this path from A to B, and on the top of this line if I write a velocity and at the bottom it's a time, and then show a mark here at every intervals of time, how much of velocity? Please remember, I am referring velocity, not the distance here. A velocity that is in terms of meters per second. Let's say that in 1 second and then in 2 seconds the velocity is either increasing or it remains same or it may reduce. And in this example, to start with, it was having 2 meter per second velocity and then it remained 2 meter per second velocity. Means a car is moving here, but moving with a constant velocity, right? Moving with a constant velocity, and again it's a 2 meter per second and then 2 meter per second and then 2 meter per second. So there is no change in the velocity. Let me write no change in velocity. You can call this velocity as speed also because it's in a straight line motion, right? In that case, what is the acceleration then? What do you mean by acceleration? Acceleration is because of change in velocity. Let me repeat, acceleration is because of change in velocity. But do we have change in velocity here? No, there is no change in velocity. It remains 2 meter per second every interval of time. Therefore, we can conclude there is no acceleration. So now you have the meaning of acceleration, which we have already studied, but we have recalled it properly, right? No acceleration because there is no change in velocity. Let us suppose if this car moved with 2 meter per second at 1 second and then its velocity changed here, right? It became 3 meter per second here. Then it became 5 meter per second here, 6 meter per second and then 7 meter per second and then so on. Now do we have change in velocity? Yes, there is change in velocity, or we can say change in speed. Okay, but as far as acceleration is concerned, we should talk in terms of velocity only, not in terms of speed, because acceleration is rate of change of velocity. Now see, initially it was 2 meter per second, then it became 3 meter per second. How much is changed? 1 meter per second velocity is changed. Now from 3 meter per second we have 5 meter per second. How much of velocity is changed? 2 meter per second velocity is changed. Now from 5 meter per second to 6 meter per second, what is the change in velocity? 5 to 6, again 1 meter per second. And then the change in velocity is again 1 meter per second, that is from 6 meter per second to 7 meter per second. Okay, look at the change in velocity. There is change in velocity and there is an acceleration. Okay, so there is an acceleration in this motion, right? However, the change in velocity is different for every intervals of time. Here it becomes 1 meter per second, then suddenly 2 meter per second, then it has come down again 1 meter per second. So there is change in velocity, right? But they are not equal change in velocity. We can say that there is an acceleration. So acceleration of the body is defined as rate of change of its velocity with time. Okay, and why do we recall this? Because to study equations of motion, okay, time and again we have to recall the definitions of acceleration, displacement and all. Sometimes we tend to forget the previous all definitions. So to start with the numericals, okay, using equations of motion, we need to understand these basic concepts properly. So how do we find the acceleration? Simple. If this is the initial velocity, it's the initial velocity. Please remember, initial velocity. And what is this? This is final velocity. So please have your attention here. Initial velocity is given a symbol small u. Look at this. So this is very important part of this video tutorial. And final velocity is small v, right? So acceleration can be change in velocity. Okay, and what is change in velocity? How much is the total change in velocity, right? So acceleration can be defined as change in velocity divided by time taken. For example, from here to here, how much is change in velocity? 1 meter per second. Look at this, 1 meter per second. And how much is change in time? Divided by 1 second. So that amounts to 1 meter per second divided by second, which is equal to 1 meter per second square, and that is what the acceleration between 1 second and 2 seconds. Now let us find out what is the acceleration between 2 second and 3 second. Okay, between 2 second and 3 second. In short, I am writing here. Okay, what is acceleration here? So what is the time? Time is between 2 second and 3 second. It's a 1 second only. But how much is the change in velocity? 3 to 5 here. 3 meter per second to 5 meter per second. So if you subtract 3 from 5, you get 2 meter per second. Now can you quickly tell me what is the acceleration? 2 meter per second square. See, acceleration is changed. Here it is 1 meter per second square and here it is 2 meter per second square. Now you can tell me what is the acceleration here, here and here. So you can do that later. Suppose if the velocity moves the way it is shown right now on your screen. If the velocity changes on the first second, at the first second, the velocity is 2 meter per second. In earlier case, it became 3 meter per second, but now it is 4 meter per second here. So what is the change in velocity here? 2 meter per second. That is 4 minus 2. And then again, 6 meter per second, 8 meter per second, and 10 meter per second. Now look at this change in velocity for every second. So you can mentally calculate now here. For this particular time interval, how much is the change in velocity? 4 minus 2, that is 2 meter per second. Change in velocity. Now how much is the change in velocity between 2 second and 3 second? 2 meter per second. And then 3 second and 4 second, 2 meter per second. 4 second and 8 second, 5 second, 2 meter per second. And then so on. Right? So what is there any acceleration here? Definitely there is an acceleration. Why there is an acceleration? Because there is change in velocity. Then how this example is different than the previous example? The difference is here change in velocity. Change in velocity is in equal amount. Look at this, equal amount. I am writing here only. So this word is very important. Change in velocity is in equal amounts. And what is that amount here? In this case, it is 2 meter per second. Every time interval, it is 2 meter per second. Equal change in velocity, right? Then this type of motion is uniform acceleration, or the motion itself is called uniformly accelerated motion. Now we have recalled what we have learnt. What is uniformly accelerated motion? Where the velocity changes in equal amount in equal intervals of time. I repeat, velocity. Okay, you have to use word velocity as far as acceleration is concerned, right? And therefore, for such motion, there are three equations which we have already studied. Now we shall again write those equations. Okay, and what are those equations? The first equation of motion is v is equal to, small v, remember, v is equal to u plus at. Now this is a very important part of this video. Now what does v tells us? This small v is final velocity. And in this case, what is the final velocity? If you take a time interval from here to here, what is the final velocity? 4 meter per second is the final velocity. If you take time interval from 1 second to 3 seconds, what is the final velocity? 6 meter per second. If you take throughout from 1 second to 5 seconds, final velocity is 10 meter per second. Now I hope you have understood what is final velocity. And then what is U stands for? U stands for initial velocity. So please remember this. You have to be very familiar with these symbols which are used. And what do you mean by small a? Small a is acceleration. Remember. And t is time taken. Now where all we can use this equation? Sometimes what do they do is that they will not give you this number 4 meter per second. So final velocity is not given, right? But they'll give you time. Time is given. Acceleration they will tell you. Initial velocity they will give you. You have to find out the final velocity. Answer should be 4 meter per second. You have to use this equation. Right? In different ways it is asked. So many manipulations, combinations of all these equations on which the problems will be asked. Okay, so please remember v, small u, small a, small t are used for these physical quantities. The second equation of motion is S, small s is equal to ut plus half at square. Now I have already told what is t. T is the time. Again a is acceleration and u is initial velocity. What does S mean? S is displacement, and you can even refer it as a distance. Why should we call it as also a distance? Okay, because in our case here distance is equal to displacement, because we are concerned with the movement on a straight line. Okay, linear motion. Number third is v square minus u square is equal to 2as. Now here what all the letters which are used? V, final velocity here, u, initial velocity, a, acceleration, and then t is not there but s is there, which is nothing but either distance or displacement. Okay, now in the numerical questions which we are going to ask in this chapter are completely related to these equations, the use of these equations. So this is very important part of this video. You have to be familiar, write down this equation as many times, and you'll be more familiar when we start solving these problems which are by using these equations, right? So till then, thank you very much.